My dear students, today I am going to discuss physics of class 10. There is a very important question. When one half of a lens is covered, how does the image change? And the answer is, size of the image remains unchanged, but the brightness of the image is reduced by half. How does it happen? Let me now explain. Consider this Ln a convex lens or converging lens. This is the principal axis of the lens and this is optical center of the lens. Now consider AB is an object. Now the image of AB is formed here, A dash B dash, which is real and inverted. Now how is this real image is formed? Let me explain. Now A is the object point. From A, innumerable rays are falling on the lens. Here I am showing you only 1, 2, 3, 4, 5 incident rays. But there are thousands and millions of incident rays. If there are 1 million incident rays, then those 1 million rays will pass through the lens and they will become the emergent rays. So you see 1 million incident rays and 1 million emergent rays. Now these emergent rays will meet at this point A dash, therefore A dash will be considered real image of A. So this is the incident beam, ALN. This is the incident beam and the emergent beam is LN A dash. Okay. Now suppose we cover one half of the lens. Just consider I am shading with pencil. Say this lower half of the lens is covered. Covered by black paper or painted black. That means we make it opaque. So half of the lens has been made opaque. Alright. So this part is opaque. Therefore these incident rays AO, AP, AN, so they will not be able to pass through the lens. Therefore these emergent rays OA dash, PA dash and NA dash, so they will not be present. Now they are absent because these incident rays are not able to pass through the opaque part of the lens. But this upper half of the lens is not covered, so it is free. Now these incident rays AL, AM, AO, so they are falling, they are incident on what? The uncovered part of the lens. So very easily they will pass through the lens and the emergent rays will meet at A dash. Therefore you see these rays which are falling on the uncovered part of the lens and passing through the lens to meet here, they will form the image of A at A dash. Similarly, the whole image of AB will be formed at A dash B dash. That means the full image will be formed. The size of the image will not change even if you have covered this lower half of the lens. But these rays, the rays falling on the lower half of the lens, they are not passing. Therefore, those rays are not available for image formation. So this will cause what? Reduction in brightness of the image. So what we see, a full image will be formed, complete image will be formed, no doubt. But the brightness will be reduced by half. Why reduced by half? Because we have covered one half of the lens. So 50% of the lens is covered, therefore the brightness of the image will be reduced by 50%. If you cover 75% of the lens, 75% of the lens, suppose up to here, up to this point, 75% of the lens from here to here you cover, then what will happen? The brightness of the image will be reduced by 70%. Similarly, if you cover 99% of the lens, 99% of the lens is covered, that means made opaque, only 1% is available for incident rays, then even that 1% which is not covered will form a full image but the brightness will be reduced by 99%. You follow? So this is how a full image will be formed, but the brightness will be reduced by half or 50% for this question. So from here we come to a rule. The rule is like this: if X% of a lens is covered, then the brightness will be reduced by X%. The full image will be formed, no doubt. Always full image will be formed. But the brightness will be reduced by X% if X% of the lens is covered. And therefore, brightness of the image will be how much? 100 minus X%. Because X% you have covered, therefore brightness will now be 100 minus X%. But the image size will be unchanged. That means always a full image will be formed. You follow? So this is the concept. Okay, thank you.